In 1921, a 20-year-old moonshiner from North Carolina was standing over the body of a dead sheriff's deputy in a clearing in the woods outside Godwin. A federal raid on his illegal still had gone wrong. Shots were fired. Deputy Al Pate was dead, and David Marshall Williams, who had been expelled from school, kicked out of the Navy for lying about his age, expelled from military academy for stealing rifles and 10,000 rounds of ammunition, and was now running bootleg whiskey operations in the backwoods of Cumberland County, was about to be charged with first-degree murder. He pleaded guilty to second-degree murder to avoid the death penalty. The judge sentenced him to 30 years of hard labor at the Caledonia State Prison Farm in Halifax County, and inside that prison, using scrap iron, wooden fence posts, and tools he built himself from junk, David Marshall Williams invented the mechanism that would make possible the most produced American military weapon of the Second World War. A weapon that armed over 6 million soldiers. A weapon that General Douglas MacArthur called one of the strongest contributing factors to Allied victory in the Pacific. The M1 carbine, born in a prison cell, built by a convicted killer, and carried by every American soldier, officer, paratrooper and marine from North Africa to Okinawa. This is how a man who should have spent the rest of his life behind bars ended up changing the way every army on Earth builds firearms. To understand why the M1 carbine mattered, you have to understand the problem it solved. And that problem had been killing American soldiers since the First World War. By the late 1930s, the standard American infantryman carried the M1 Garand, a magnificent semi-automatic rifle that was arguably the finest infantry weapon of its era. But the Garand weighed nearly 10 pounds loaded. It was over 43 inches long. It fired the powerful .30 caliber Springfield cartridge, which had bone-jarring recoil, and was designed for engaging targets at ranges of 500 yards or more. The problem was that not every soldier was a rifleman. Officers, drivers, radio men, mortar crews, artillerymen, medics, engineers. The majority of an army is not frontline infantry. These men needed a weapon for self-defense, not for engaging enemy positions at long range. What they carried was the M1911 pistol, a .45 caliber handgun that was effective at about 25 yards and useless beyond that. In between the full-power rifle and the nearly useless pistol, there was nothing. No lightweight, accurate, semi-automatic weapon that a non-infantry soldier could carry without being weighed down and still defend himself if the enemy showed up at his position. The army knew this was a problem. In 1938, the Ordnance Department issued a requirement for a light rifle, a weapon weighing no more than 5 pounds that could replace the pistol for rear echelon troops. It had to be semi-automatic, it had to be accurate out to 300 yards, and it had to be simple enough for a truck driver or a radio man to use without extensive training. The problem was that nobody knew how to build one. A semi-automatic rifle needs a mechanism to cycle the action, to eject the spent cartridge, load the next round, and cock the firing mechanism all automatically, using nothing but the energy of the fired round itself. In a full-size rifle like the Garand, this was accomplished with a long-stroke gas piston, a heavy, robust system that used propellant gas tapped from the barrel to push a piston that drove the bolt backward. It worked beautifully, but it was heavy. The piston, the operating rod, the gas cylinder, all of that added weight that a light rifle could not afford. To build a weapon light enough to replace the pistol but powerful enough to be effective at 300 yards, someone needed to invent a completely new way of cycling a semi-automatic action, something lighter, something shorter, something that could deliver just enough force to operate the mechanism without adding the bulk of a traditional gas system, and that someone was sitting in a prison cell in North Carolina drawing firearms designs on scraps of paper by lamplight. David Marshall Williams was born on November the 13th, 1900, in Cumberland County, North Carolina. His father, James Claude Williams, was a wealthy landowner with hundreds of acres of farmland around the town of Godwin. David was the eldest of 7 children from his father's second marriage, with 5 half-siblings from the first. He grew up working on the family farm, learning to use tools before he could properly read. School did not interest him. He was expelled in the 8th grade. After that, he apprenticed in a blacksmith shop where he learned to work metal the old way, heating it, hammering it, shaping it by hand and by eye. He developed an intuitive understanding of how metal behaved under stress, how to judge the temper of steel by its colour, how to weld and join and cut with a precision that no classroom could teach. At 15, he lied about his age and enlisted in the United States Navy. They found out he was underage and discharged him. He enrolled at Blackstone Military Academy in Virginia. He was expelled for stealing several rifles and over 10,000 rounds of ammunition from the Academy Armory and shipping them home. In 1918, he married Margaret Cook. He worked briefly for the Atlantic Coastline Railroad, and then he found a more profitable line of work. He started building and operating illegal whiskey stills in the woods of Cumberland County. Prohibition was in full swing. Moonshine was good money, Williams was good at building things, and a whiskey still is at its core an engineering problem. Heat management, condensation, flow control, material selection. He ran multiple operations. He was careful. But on a night in 1921, federal agents and local law enforcement raided one of his stills. In the chaos, shots were fired. Deputy Sheriff Al Pate was killed. Williams always denied pulling the trigger, but he was charged, and he pleaded guilty to second-degree murder to avoid a capital sentence. The judge gave him 30 years. At the Caledonia State Prison farm, Williams was assigned to hard labour like every other inmate, but the prison superintendent, a man named H.T. Peoples, noticed something unusual about the new prisoner. Williams could fix anything. Hand him a broken tool, a jammed lock, a malfunctioning piece of farm equipment, and he would have it working again within the hour. Peoples, who by all accounts was an extraordinarily perceptive man, made a decision that would change the course of firearms history. He transferred Williams to the prison machine shop and gave him increasing freedom to work. Williams did not waste the opportunity. He started by building tools the prison needed but could not afford to buy. Lathes, jigs, clamps, precision instruments fashioned from scrap metal with nothing but hand tools and a blacksmith's forge. He built a small lathe from automobile parts. He fabricated cutting tools from old files. He turned the prison machine shop into something closer to a proper firearms workshop than anything that had a right to exist inside a penitentiary. Then he began servicing the weapons carried by the prison guards, cleaning them, repairing them, improving their function. The guards noticed that their weapons worked better after Williams touched them. Word got around. Peoples gave him more latitude, and then, with nothing but time and the crude equipment he had built himself, he started designing firearms from scratch. His mother sent him a drafting set. She also sent him paperwork for filing patents, though he could not actually patent anything while incarcerated. He spent his nights drawing, sketching mechanisms, calculating forces, working out how gas pressures and spring tensions and bolt masses interacted inside a weapon's action. He did not have textbooks. He did not have reference materials. He worked from first principles and from an instinct for metal that he had developed in the blacksmith shop as a boy. Over the next several years, Williams built 4 complete semi-automatic rifles inside a prison. The first was constructed from scrap iron and a wooden fence post. Think about that for a moment. A man with no formal engineering education, no access to proper materials, no machine tools beyond what he had fabricated from junk, built a functioning semi-automatic rifle from a fence post and scrap metal in a prison workshop. And in the process, he invented 2 mechanisms that would revolutionize every semi-automatic weapon built for the next century. The first was the floating chamber. This was an ingenious solution to a specific problem. how to make a low-powered cartridge generate enough energy to cycle a semi-automatic action. In a conventional design, the cartridge's propellant gases push the bullet forward and simultaneously push back against the bolt. With a weak cartridge, there is not enough rearward force to reliably cycle the action. Williams designed a chamber that floated freely inside the receiver. When the cartridge fired, the forward-moving gases pushed against a small step machined into the floating chamber, driving it backward with additional force that supplemented the normal blowback energy. It was like adding a second push to a door that was almost, but not quite, heavy enough to swing open on its own. The floating chamber provided that extra push. It meant that small, low-powered cartridges, like the .22 caliber long rifle, could now reliably operate semi-automatic and even fully automatic weapons. The military application was immediate. Training soldiers with expensive full-power ammunition was wasteful. With Williams's floating chamber, training weapons could fire cheap .22 ammunition and function identically to their full-power counterparts. The second invention was far more important: the short-stroke gas piston. In a traditional gas-operated rifle, propellant gas is tapped from the barrel through a small port and directed into a cylinder where it pushes a piston. The piston is connected to the bolt by a long operating rod, and as the piston moves backward, it drives the bolt back with it, ejecting the spent case and compressing the return spring. The problem is that the piston, the operating rod, and the gas cylinder all add significant weight and length to the weapon. In a full-size battle rifle, this is acceptable. In a 5-pound light carbine, it is not. Williams's solution was elegant in its simplicity. Instead of a long piston connected directly to the bolt, he used a short piston, a small cylinder that travelled only a fraction of an inch. When the gas hit the short piston, it gave the piston a single sharp blow. The piston transmitted that impulse to the operating slide through a brief violent tap, like flicking a marble with your finger rather than pushing it with your hand. The piston itself barely moved, but the energy transferred to the operating slide was enough to drive the bolt back, eject the case, compress the spring, and chamber the next round. The genius of the short-stroke system was its weight savings. The piston was tiny, the gas cylinder was minimal, there was no long operating rod running the length of the weapon. The entire mechanism added ounces instead of pounds. And because the piston disengaged from the operating slide almost immediately after the initial impulse, the bolt carrier was free to travel independently, which reduced the total mass of moving parts and made the weapon faster, smoother, and more controllable. This was not an incremental improvement. This was a fundamentally new way of making a firearm work. Every modern gas-operated weapon that uses a short-stroke or tap-it gas system, and that includes the M16, the AR-15, the M4, the FN SCAR, the Heckler & Koch G36, and dozens of others, traces its mechanical lineage back to a design sketched on scrap paper in a North Carolina prison by a convicted murderer with an 8th grade education. News of Williams's inventions leaked out of Caledonia in 1928. The Charlotte News ran a story announcing that an invention that might revolutionize the firearms world had been perfected by a prison inmate. Within days, the Colt Patent Firearms Company sent representatives to interview him. They were impressed. Meanwhile, Williams's family and friends in Cumberland County launched a campaign to have his sentence commuted. The sheriff who had arrested him joined the effort. Remarkably, so did the widow of the deputy he had been convicted of killing. In September of 1929, Governor Angus MacLean commuted his sentence. David Marshall Williams walked out of Caledonia State Prison after serving 8 years of a 30-year term. He went straight to Washington and showed his inventions to the War Department. His first contract was to modify the .30 caliber Browning machine gun to fire .22 caliber training ammunition using his floating chamber. He succeeded. Colt used his floating chamber in their semi-automatic pistol, Remington used it in a rifle. The Army adopted it for training weapons. Then came the contract that changed everything. In 1940, the Winchester Repeating Arms Company hired Williams and licensed his short-stroke gas piston patent. They assigned him to improve a semi-automatic rifle that Winchester was developing as a potential replacement for the M1 Garand. Williams fitted the rifle with his short-stroke piston, creating the Model G30M. The rifle did not replace the Garand, but the piston system worked beautifully. When the Army announced its light rifle competition in 1941, Winchester knew they had the key technology. The challenge was building a complete prototype in time for the trials. Williams, who was brilliant but notoriously difficult to work with, clashed with the other engineers on the team. Winchester assigned 2 employees, Fred Humston and William Romer, to lead the project. Williams was furious at being sidelined and refused to cooperate. Humston and Romer built the first prototype in 13 days. The receiver, the rotating bolt, the slide, and the short-stroke gas piston were all based on Williams' designs. When the prototype had last-minute problems, Williams was brought back in to help solve them. The team submitted their entry just before the deadline. On September 30th, 1941, the Winchester light rifle was officially adopted as the United States carbine, caliber .30 M1, the M1 carbine. What followed was one of the greatest mass production achievements in American military history. The M1 carbine was not manufactured by Winchester alone. The demand was too enormous for any single company. Contracts were awarded to 10 different manufacturers, including companies that had never built a firearm before: the Inland Division of General Motors, IBM, the National Postal Meter Company, the Rockefeller Jukebox Company, and others. A jukebox manufacturer building combat weapons. That is what total war looks like. By the end of the war, over 6 million M1 carbines had been produced. 6 million. That made it the single most manufactured American military weapon of the entire conflict. More than the Garand, more than the Thompson, more than the M1911 pistol. Pause and think about what that number means. If you lined up 6 million carbines end to end, they would stretch from New York to Los Angeles and back again. One factory, the Inland Division of General Motors, alone produced over 2.5 million of them. And the comparison to what the enemy had tells you everything about why the carbine mattered. Germany had no equivalent. Their rear echelon troops carried the same bolt-action Kar 98K that frontline infantry used, a full-size, full-weight battle rifle that was overkill for a supply clerk and a burden for anyone who was not a trained rifleman. Japan had nothing comparable either. Their officers carried swords and pistols. Their rear area troops were often armed with weapons from the previous century. Only America had a purpose-built, lightweight, semi-automatic weapon specifically designed for the millions of soldiers who were not riflemen, but who still needed to fight. The M1 carbine filled a gap that no other army on Earth had even recognized as a gap. And Williams's short-stroke piston was the mechanism that made it possible, and the soldiers loved it. At 5.5 pounds loaded, it was nearly half the weight of the Garand. It was 18 inches shorter. It was fast to aim, fast to fire, and gentle enough in recoil that a clerk or a driver who had never fired a weapon in anger could pick it up and use it effectively with minimal training. Paratroopers carried the folding stock M1A1. Officers carried it instead of the pistol. Radio men carried it instead of nothing. Tank crews, mortar teams, medics, engineers, every soldier who was not a frontline rifleman suddenly had a real weapon instead of a sidearm. Let me put you behind an M1 carbine for a moment. It is February of 1945. You're a radio man with the 4th Marine Division on Iwo Jima. Your primary job is keeping communications open between your company commander and the battalion headquarters behind you. You're not a rifleman. You did not train for close combat. You carry a radio on your back that weighs 38 pounds, and strapped across your chest is an M1 carbine that weighs 5. The Garand would have been too heavy to carry alongside the radio. The pistol would have been useless beyond arm's length. But the carbine is light enough to carry all day, short enough to swing up fast in a trench, and accurate enough to hit a man at 200 yards. And on Iwo Jima, where Japanese soldiers emerged from tunnels behind your lines at 3 in the morning with bayonets fixed, the carbine is the only reason you are alive in the morning. In the Pacific, where Japanese infantry tactics included infiltrating rear areas and attacking supply lines at night, the M1 carbine saved thousands of lives that the M1911 pistol never could have protected. On Guadalcanal, Marine raiders carried carbines through jungle so thick that the 43-inch Garand was nearly impossible to maneuver. The carbine's compact length let them push through undergrowth, swing the weapon up fast, and fire accurately at close range, exactly the kind of fighting the Pacific demanded. On Saipan, on Peleliu, on Iwo Jima, rear area troops who would have been defenseless with only a pistol suddenly had a weapon that could reach out to 200 yards with genuine stopping power. In Europe, paratroopers of the 82nd and 101st Airborne Divisions jumped into Normandy on the night before D-Day carrying the M1A1, the folding stock version of the carbine designed specifically for airborne operations. The stock folded sideways against the receiver, creating a package compact enough to strap to a paratrooper's leg. When he landed, assuming he survived the jump, the anti-aircraft fire and the chaos of a night drop behind enemy lines, he could unfold the stock and have a functional semi-automatic weapon ready to fire in seconds. Thousands of American paratroopers fought their way through the hedgerows of Normandy with carbines because the weapon was light enough to jump with and effective enough to fight with once they hit the ground. At the Battle of the Bulge in December of 1944, the carbine's limitations were exposed in the bitter cold. The lubricants in the action thickened in sub-zero temperatures, causing stoppages. Soldiers learned to run their carbines nearly dry, minimal oil, just enough to prevent rust, and the reliability problems largely disappeared. The weapon adapted because the soldiers adapted. And even with its cold weather issues, every officer, every radio man, every artilleryman in the Ardennes was grateful to have a carbine instead of a pistol. When German infantry came through the fog, General Douglas MacArthur called it one of the strongest contributing factors to Allied victory in the Pacific, and he was not exaggerating. The M1 carbine did not win firefights against entrenched positions at long range. That was the Garand's job. What the carbine did was ensure that every American soldier, cook, clerk, driver, radio man, could fight back when the enemy came for them. And in a war where the enemy came for everyone, that mattered more than most people realize. The M1 carbine served through Korea, where it was standard issue for South Korean forces and widely used by American troops during the bitter winter fighting of 1950 and 1951. Marines at the Chosin Reservoir carried carbines alongside Garands during one of the most brutal retreats in American military history. It served in Vietnam, where South Vietnamese soldiers and American advisors carried it through the early years of the conflict before the M16 replaced it. A select fire version, the M2 carbine, capable of fully automatic fire, was developed near the end of the Second World War and saw extensive use in Korea and early Vietnam. The M1 carbine was exported to dozens of nations: France, Italy, West Germany, Israel, the Philippines, Thailand, South Korea, Japan, Ethiopia, and many others. Israeli forces carried carbines during the 1948 Arab-Israeli War and the Suez Crisis. French paratroopers used them in Indochina and Algeria. Police forces across the United States used them for decades. Some are still in active service today in parts of the developing world, more than 80 years after the design was adopted. The carbine's DNA lives on in ways most people never notice. Every modern short-stroke gas piston system, from the AR-18 to the Heckler & Koch G36 to the FN SCAR, owes a mechanical debt to the principle Williams invented on a prison farm in North Carolina. In 1952, MGM released a film called Carbine Williams, starring Jimmy Stewart as David Marshall Williams. The movie dramatized his story: the moonshining, the shooting, the prison sentence, the inventions. It was Hollywood, so the details were polished and the rough edges smoothed. The real Williams was harder than the movie version. He was stubborn, combative, impossible to manage, and frequently drunk. He clashed with every employer he ever had. Winchester's own records describe him as a gifted designer who was a major distraction to the smooth operation of the company. But none of that changes what he built. After the war, Williams returned to his family farm in Godwin, North Carolina. He built a workshop on the property and spent the next 30 years refining firearms designs. He received 40 patents over the course of his career. Politicians and reporters visited him regularly. The governor appointed committees to honor him. The North Carolina Museum of History acquired his entire workshop, nearly 3,000 artifacts, and put it on permanent display. He died on January 8, 1975, at the age of 74. The relatives of Deputy Alpate never forgave him. As recently as 1997, they publicly objected to the honours given to the man convicted of killing their family member, and they had every right to object. David Marshall Williams was not a hero in any conventional sense. He was a violent man who made whiskey in the woods and ended up in prison because someone died. The story is not simple. The man was not simple. History rarely is. But inside that prison, with nothing but scrap metal and time and an 8th grade education and an instinct for how metal moves under force, he invented a mechanism that armed 6 million American soldiers in the deadliest war in human history. A mechanism that is still used in nearly every modern military rifle on Earth. A mechanism that started as a sketch on scrap paper in a cell in North Carolina and ended up in the hands of every soldier who waded ashore at Normandy, every paratrooper who jumped into the darkness over France, and every Marine who stormed a beach in the Pacific. They gave him 30 years. He gave them the M1 carbine. The prison got the worse end of that deal.